How many of you actually refer to a map ever? Or do you just go it blind? No hands? Few of you look at a map. I know everybody's probably completely plugged into their geographic location at all times, but I usually like to have a map so that I know where I'm going, and that's what's indicated here in terms of the technical electives or how they're supposed to be organized. We do them by decades, and really they sort of start in the 20s, and then they move on up to and through the 80s. But if you associate those decades with what you've already taken, if you're now a junior or a senior, particular prerequisite courses. If you look at this course line, I'm not going to call it a timeline, but the course line we have in the 20s, you have 220 and 320. Those are sort of circuits and signals systems type classes. That's now going to begin the 20s, 30s, and 40s. Those 3 decades contain, hopefully, sometimes it varies, so don't get locked in and argue with me that one of these classes is not in the right decade. Planning is not perfect. But the 20s are supposed to be signal processing type classes. The 30s are communications. The 40s are control. And those 3 classes or categories of topics represent signals and systems. Then we move into the 50s, which you've maybe had 351C or 352. Those are electronics. The 60s and 70s are the computer decades, and you've had 175, 275, 274, 372. All of those are in the 70s, and maybe you've had 369. That's one in the 60s. And then the 80s are electromagnetics and optics courses, and if you're in the electrical engineering track, you've taken 381A. Those then in red are typically prerequisites for the subsequent courses in the 400s that we're going to be talking about today. And we will start with what you're going to be registering for next semester, which is fall 2018. And hopefully this will be somewhat static from this point forward, but always be checking your email, checking websites to make sure that some of these classes haven't changed, or maybe we've introduced or inserted some new ones. We are interviewing faculty this spring semester, and maybe we will have some new faculty teaching some additional classes come fall or spring, and we'll try to let Sydney know so that she can inform you of what's happened. But relative to fall of 18, if you are in the electrical engineering option, you can actually take 369A, which is computer architecture, assembly language, how do you build a computer essentially, or what are the component parts of a computer. If you're in the EE option, you can take 369A as a technical elective. Similarly, I see a lot of heads nodding. So we'll go on to 373. We can also, if you're in the electrical engineering option, you can take the object-oriented programming class in ECE 373. ECE 4/513, and those are dual numbered classes. The reason why I'm listing those as dual numbered is if you are interested in the AMP, you have the opportunity to take graduate level courses to count both towards your undergraduate education and your graduate education. And knowing that 413 has a graduate 513 section associated with it allows you to take that if you wanted to for your AMP units. But 413, 513 is web development and Internet of Things. Yes?
So as far as that goes, those classes that we have to enroll for the 513, we want to go towards unaccelerated, or do we need to either one work?
So the question was, which one do we register for if we want to apply it in the AMP? You would if you want that particular class to be one of your AMP counted classes, which means you're double dipping, you're counting it for both your BS and your MS, you would use the 500 level version. You can't take the 400 level and then say, oh, I want to use this. You're out of luck. You won't be able to use it towards your graduate degree. And we'll talk a little bit more about the AMP. I was just trying to tell you why in the world is he showing me the 500 level classes. It just gives you a feel for what you might be able to take. And you can only count four, both at the four courses, for 3-unit standard courses for both your BS and your MS degree. Web development and Internet of Things, how do you connect things and communicate and keep track of those through the web? You learn how to design the back inside the web, etc. to do that. ECE 474A is really Digital Logic 2. You've all had or will have had ECE 274. This is now the second semester of that. How do you put things together in terms of computer logic, and how do you think through those particular designs? ECE 474A is the computer networks. How do you network computers? What does that mean? How do they communicate? What are those protocols, and how do you make those work? Hopefully this chair is not being picked up, but if you hear something squeaking, it's not my body, it's actually the chair that I'm sitting in. So if you're listening to this either live or later, you'll wonder, what was I hearing? Well, it's my body. That's what happens when you age, okay? It starts needing lubrication. I need to oil it. So now we have electronics and bioengineering classes in the 50s. And again, these are for fall of 18. And if you're planning, plan a year at a time for your technical electives. Don't think that these will all be offered in the spring. Most of them won't be. They will only be offered in the fall. So if you're going to graduate in spring of 2019, you probably want to make sure that you pick these up in the fall semester, because they probably aren't going to appear in the spring of 19 semester, a year from now. 450 is analog integrated circuits. That's a follow-on to 351C. You maybe go a little bit further. Maybe in 351C you're doing op amps and transistor-based circuits. Now just stack those up or make those a little bit more complicated, and you now have the contents of 450, 550. 434, now that one is dealing with the electrical and optical properties of material. So how do you make sensors, or what kinds of material goes into a particular device, and how do I understand those electrical and optical properties of some particular subsystem that you might have to work with or design or use in your future. If you wanted to know how do you create a semiconductor device, how do you manufacture that, then you might be interested in 446, 546. And I apologize if I get the numbers interchanged, but hopefully you can see what I'm trying to say if I say them out of line. But here is 446, 546, which is the semiconductor processing. Those are in the 50s. In the 80s, if you're in the computer engineering option, you can take 381A, which is the introduction to electromagnetics. Now, how do transmission lines work? Maxwell's equations. If you wanted to know and understand Maxwell's equations, here's the class for you in terms of understanding that, and now really understanding maybe some of these higher level relationships that we've been playing with in circuits. Now what does it really look like in the physics? How does that actually happen? Then Some of these, I'm not sure if they will be offered, so take some of this with a grain of salt. I'm not sure that we will offer 459, 559, but if we do, that's the fundamentals of optics for electrical engineering. If you wanted to step into optics from an electrical engineering perspective, this is a good class to do that. How to understand what equations, what physics are needed or necessary to give you the foundational material for optics. If you've been following along with this in years past or semesters past, here's a little bit of a change. Starting with the fall of 2018, we are going to teach 429, 529 digital signal processing in the fall semester. It won't be offered in the spring, so don't plan on it being taught in spring of 19 like it's being taught in spring of 18. 429, 529, digital signal processing. Now, how do you do things in a computer in terms of signal analysis and computation and filtering? That's now digital signal processing. How do you build a communication systems that's optically based? That's 430, optical communication systems. And then how do you make a system, model it, and maybe change its dynamic behavior or make it move the way that you want or behave the way that you want? That's now automatic control, which is for 41A, 541A. How do you build something that will track or perform the way that you want it to perform? Everyone has their eye apparatus on. Here's an eye chart. Or another way of saying this is now how to maybe plan out your schedule. And again, I'll try to make this available so that you aren't going to have time to digest that now in 2 minutes, but this shows you the overlaps between the different courses that we are planning to offer in the fall schedule of 2018. And you can see then that some of these only have one class in a particular slot. Then you don't have to worry. That one you can take unless there's some non-ECE class that you're taking, a math class that's in that particular time slot. But this is a way to initially say, oh, I want to take these 4 technical electives in the fall of 18. You can look at this and see, oh, good, none of them overlap, so I can, in terms of time, take all 4 of those that I wanted to take. That's the purpose of this. It's not, the purpose of this is not, oh, when can I sleep? Okay. Because you want to be up by 9 a.m. to take that controls class on a Monday, Wednesday, Friday. Just saying. Any questions on the fall? Similarly, you'll be ready to go at 8 a.m. on Tuesday, Thursday to take 373 or the computer networking class. No hands. Pardon? Do I write those schedules? How much do I want to admit? Actually, these schedules are fairly historical, but occasionally we do have changes that are made, and the main concern in making these is not so much the time of day, it's really trying to avoid overlap or conflict. And if there are 2 that are overlapping and you see that, you can let us know. There might be something that we can do about that, but I won't make any promises. It's very hard to find classrooms in the peak hours during the day, and that's why we're going all the way until, for example, 6:30 on some days. Spring of 19. If you were supposed to take the fall schedule with a grain of salt, this one you're going to need a teaspoon of salt in terms of how do you take this one. It's a little ways out there, but you can sort of plan around what I'm suggesting now. And again, like I said, plan a year at a time. Don't plan one semester at a time or you may be disappointed. In the computer decades of the 60s and 70s, and here you can see that we're not sticking to that script. ECE 330B is computational techniques. How do you maybe make these algorithms or this analysis work more effectively? That's ECE 330B. And that you could think of as sort of lying in the computer area or in the computer topic region. If you wanted a second semester of computer architecture, that's 462. A follow-on, or if you're interested in cryptography, how do you keep things secure? That's 471 in Fundamentals of Information and Network Security. How do you keep that as secure as possible? And if you're interested in artificial intelligence, that's 479, 579. In the 50s or in the electronics and bioengineering area, 304A is again another second semester of 351C. It's a follow-on. This one actually has a lab component, so if you liked the lab of 351C, you can go a little bit further in 304A. 352, is that right? Spring. Yeah, we've changed it. I thought I'd done this right, and then I go, now which one am I doing? So 352 is not going to be every semester anymore, starting with next year. Actually, it probably never was. It was this year that it was twice in the year, 2017-18. Now, moving forward, we're trying to put it in the spring semester. And that one is required of those in the electrical engineering track. That's why the CE is in parentheses. If you're in the computer engineering option, you can understand device physics a little bit better after taking 352. If you wanted to understand how to instrument your body or keep it from squeaking, possibly, then this particular class, 417, is measurement and data analysis and bioengineering. You now put things on you or around you or in contact with your body. You measure those and you walk up and down the hall and record data, etc. And now you can see an application of some of your electrical engineering expertise. Electricity, or EMO, electricity, magnetics, and optics. You have the photovoltaic solar energy systems. That one, you'll want to make sure that you're at least in senior status. Right now, maybe the prerequisite structure is not as explicit as it needs to be, but you probably want to have a little understanding of device physics, maybe some electromagnetics before you step into 414A, 514A. How do you now build a photovoltaic device? And how might you improve that or enhance that or make it better? If you always wanted to know how do these devices work that we carry around with us that have antennas, and now our packaging is getting smaller and smaller, how do they put that antenna in such a small device? That's now 484, which is antenna theory and design. In the signals and systems, or signal processing, communications, and control decades, there's two classes in the spring. Digital communications, which is the 435A, and digital control, which is the 442. Like we did for, and here I've tried to really indicate that this is tentative, but you can see that we are trying to minimize conflict or overlap between the various classes. And in particular, hopefully most of those that are overlapping are not necessarily in the same century, meaning you might have a 300 overlapping with a 400, but hopefully not too many 400s, although a lot of times we do have faculty that like to teach in prime time, and we're trying to spread that out a little bit. Questions on technical electives for 2018, 2019, fall and spring? Yes?
How should we think of the difference between automatic control systems and digital control systems?
So those particular classes are, the question was, what's the distinction or difference between digital control, the 442, and the automatic control, which is 441A, and really the main difference, or the big difference, is one is analog or continuous time. That's the foundation, and the other one is working in discrete time. But they are somewhat parallel. If you take one of those, you'll sort of see the parallel topics in the other domain, either continuous time or discrete setting. But I think, as of now, I will probably be teaching this in the fall, and I like to have a lab component to that. It's on your own, but now you get to go into the lab and measure or try to identify a system physically, and you make it move around, and you say, oh, what's the transfer function? And you can figure that out by the measured data. Then you learn how to control it in the analog setting. In 442, you're now sampling that time axis, and you're doing everything. And so if you can only take so many, I would suggest taking maybe a digital signal processing, a 429, and an analog control. Or if you can take all three, then yes, you could take 429, 441A, and 442, but you wouldn't necessarily. 442 and 429 are very complementary. There's a lot of overlap, I would say, with learning how to do Z-transforms, playing with the discrete time signal processing aspect of analysis. Did that answer your question on the distinction between 441 and 542 or 442? Other questions? I promise the answer won't be as long.
I didn't see AI2. Is that going to be offered in the future?
So AI2 might be offered in the future. I shouldn't have said AI1, should I? And then I wouldn't have prefaced or that. So is AI1 and AI2, faculty move around and shift around, and the best I know as of today, we only will have enough faculty resources to teach one artificial intelligence class in next academic year. And so that will be the 479, 579. The following year, we might teach both. We might teach 479 and the other AI2, although you don't have to take one before the other, is 466, 566, but you don't see that on the schedule for next academic year.
And complexity, is that one also not going to be offered in reverse engineering class?
Complexity probably won't be offered next year, and now I've forgotten the number for that. And reverse engineering the fly, pardon? Oh, 521. Oh, you know, if you are looking, maybe I can try to post this. I know this is not the best for you to see, but this is now essentially the course catalog. I'll try to post this, and you can read up on what it is that you might want to take. So I would suggest you look at the classes that we've suggested are available, and then do a little bit of digging on this to see at least the course description and see if that's consistent with what I've said or what you think the class will be, and then make your call after that sort of background work. And I'm not sure. I was just talking with somebody earlier about, now I thought I knew where it was, but I'm not seeing it. But reverse engineering the fly, I don't know that that will be offered. And that some of these technical electives are actually home-based out of other departments. And that's why I don't know about reverse engineering the fly. The main instructor for that is not associated with the electrical and computer, or is not housed in electrical and computer engineering. Other questions on the technical electives? Yes.
So yeah, what are the chances that some of the classes of tech electives that you just mentioned were to be canceled?
So what are the chances that any of the classes that I've mentioned will be canceled? I would like to say very slim, but I know better. Things happen between now and fall, so I can't guarantee that these will be taught, but I'm pretty comfortable with most of them. The ones that I'm not that comfortable with would be the 459, 559, the Fundamentals of Optics for Electrical Engineering. That one I'm not sure of. And some of them, the ones that I'm not sure of for the fall, I didn't even put on here.
Sorry to say one also, 569 is that one that is possibly going to be there?
So 569, I didn't list the 500 level classes in the penciled. That might be in the spreadsheet, and that one, it might be offered next spring of 19, the high performance computing, 569. But in preparation for this info session, I was now trying to plan who's not here next year, who is, and how are we sequencing through some of these classes. And it might be that 569 is taught a year from now in spring of 2019. But faculty have a way of changing that. Yes. And hopefully I will be able to make this available at that web address. Okay? An old clunky address. If you think the technology that I'm sitting in and using to record is clunky, well, maybe that web address and that website is clunky, but at least you have the data. Okay? And maybe even the captured video. Other questions? Let's then move on to the Accelerated Master's Program. And this is actually a pretty good deal if you're interested. It's really designed to provide you the opportunity to finish a master's degree 1 year after you finished your bachelor's degree. And the way that it does that is it allows you to count 4 classes or 12 units for both degrees. Meaning if you take 4 graduate level classes as an undergrad, you can then count those towards your graduate. And a graduate degree, a master's program in ECE, consists of 10 3-unit classes. And that's now getting it down. If you've now counted 4, you now take 6 classes in your last year, or 3 a semester. That may sound like a piece of cake now that you're taking 5 or 6, but usually graduate classes are a little bit more demanding of your time. And so 3 is a pretty good schedule, a pretty full schedule to be taking on 3 a semester. That's the program very quickly, but if you're thinking of doing that, you can actually apply to the AMP, that's what I'm going to call it, but it's the Accelerated Master's Program. You can actually apply if you've acquired or accumulated 75 undergraduate units. You can't start until you've completed or you've now acquired 90 units. So you have to be an official senior in order, and that's what the 90 units is for, to start taking classes towards your BS/MS degree. The other thing that's nice about this is we actually waive, where is it? We waive the GRE requirement. That's the graduate record examination. You don't have to take that if you're accepted into the master's in the AMP. You do have to have a 3.3 cumulative undergraduate GPA when you apply, and I believe you have to maintain that over the course of your undergraduate degree. So you have to graduate with a 3.3, or otherwise you're going to have to sort of pay back or take additional coursework because those others won't count towards your master's degree. But if we stay positive, then you'll have 4 classes that you can count both as an undergrad BS and 4 toward this, those same 4 towards your MS. And if you're interested in this, probably you want to immediately start, I'm looking for my notes if I can find those. I think I know what it is. But you'll want to work with our graduate advisor, which is Tammy Whalen, and you can reach her at the following email address. And she would be happy then to work with you in terms of planning what it is that you need to do in order to, 1, apply, and 2, go through the AMP program. Whoops. This maybe isn't right. Is it? It probably would work. It's ECE, I think. It's Grad Advisor ECE.arizona.edu. So you can start this as long as you're a senior, and that means you have to have 90 or more units. But you want to probably apply when you get into the 75 unit range, unit-wise. What have I failed to mention?
Up to 4.
It's up to 4. So the comment is you don't have to take 4. You could take 2 as an undergraduate, but then you would need to take 8 more towards your graduate degree. And I don't know, this is on the record, I guess, since I'm being recorded, but you could possibly go get a job and fulfill your MS degree doing online coursework. It doesn't have to be in the next immediate year. And so now you have a company paying for your master's degree, and you really still only need 6 courses beyond your BS if you're in the AMP program. I hope that that's truth in advertising. I think it is. Was there?
So you can do both. You can either stay on campus.
Yes.
Or you can switch to the online, the fully online.
So you could stay on campus. Maybe you even find a job locally. You wouldn't have to take those 6 units in the next academic year. You just have to finish, I think, in maybe 6 years total to fulfill your MS degree program. Question? So will these credits be transferable to another university? And the answer is no. So you won't be able to transfer these to another university. If you finish the AMP and you decide not to go on with your master's degree, you haven't really lost anything other than maybe you've lost the use of those 4 classes towards an MS degree. But you could go somewhere else and pursue a master's degree. You just won't be able to count those 4 classes towards your master's degree somewhere else. So this is designed to essentially accommodate your BS MS here at the University of Arizona. But it's not, you don't have much to lose, really, if you decide you do it, and then at the end of your senior year you decide either to not pursue a master's or you decide to go somewhere else for your master's. Now you've sort of learned what a master's course might look like. You've maybe convinced yourself that it's doable, and maybe you want to move to a different program. That's fine. It won't keep you from doing that. Any other questions? Yes. So the credits is my understanding, it's your U of A credits that you have, and if you had
overall, so transfer units, U of A credits, test credits like AP.
So it's whatever you have in your sort of on your record as you're matriculating through. If you transferred in with 60 units, you now have 60 units and you start counting or adding to those 60 in your junior year, for example. And then if you take 30 units in your junior year, you've got the 90 to begin this program. Now the GPA will be based on your U of A GPA, and that's a cumulative GPA of 3.3. So if you transfer in with a 4.0 from somewhere else, you'll have to start fresh with your U of A GPA. Other questions? If not, thank you for your attendance. I hope this was helpful, and if you need to listen to it again, you should have that opportunity if this works. Good.